here's an example how we would use Boyle's law. What's the new volume? So I'm looking for a volume. So I'm going to say I'm looking for volume, and I'm going to call it volume 2. Okay. If 1.5 liter sample of Freon is at 56 torr, is compressed to 1.97 atm. So we have a gas being compressed down. So my volume initial is equal to 1.5 liters. So I start off with this volume, okay, and my pressure is going to change. So my pressure started at, oops, that'd be pressure. Pressure 1 was equal to 56 torr. Okay. Notice what I'm doing here. I'm listing the information from the problem. What am I looking for? And I list the information. Pressure 2 is equal to 0.197 atmosphere. All right, here's a problem because I have two different pressures, two different units. I'm going to have to unify those units. I'm going to have to get them to match. So to do that, what I'm going to do is get rid of my torr, 760 torr, and I'm going to put at the top 1 atm. If I do that, I can find that my pressure 1 is equal to 0.0737 atmosphere. Okay, so that's what my original pressure is in atm. So let's kind of separate this out a little bit so we can see the difference here. So what I'm going to do is I'm going to use Boyle's law. Boyle's law is pressure 1, volume 1 is equal to pressure 2, volume 2. What I'm solving for is volume 2. So I'm going to take this side and divide both sides by pressure 2. And what I'll do is this will cancel, this will cancel. So my final volume is equal to pressure 1 times volume 1 over pressure 2. So now I can plug into my equation and I can predict what my new volume would be. And this comes out to be 0.561. And how many significant figures? I have 2, 3, 2, so I should have 2 in my final answer. So 0.56 liters is my final volume. So that would be the final volume that I reach. Now let's think about this. Does this make any sense? My volume starts out at 1.5, so I have a 1.5 liter container, okay? And my pressure is 0.073. So what's happening to pressure? Pressure is going from 0.07 to 0.197. So my pressure is going up. So if my pressure goes up, what should happen to the volume? Volume should go down. So I should get a smaller container when I'm finished. My volume started at 1.5 liters and it ended at 0.56. So conceptually it makes sense and we can think about it, it fits, and we're in good shape. Okay? All right, so that's Boyle's law. We'll have how to do calculations with Charles' law. All right, so we've got a gaseous sample of krypton maintained at a constant pressure. It's found to have a volume of 10.5 liters. All right, so we got a volume 1 of 10.5 liters. Temperature is equal to 25 Celsius. All right, and my volume, or I'm sorry, my final volume is what I'm looking for, and my final temperature is going to be 250 Celsius. Okay, so right away, since I know what I'm looking for is volume and temperature, I know I'm going to be using Charles' law. V1 over T1 is equal to V2 over T2. Well, since I'm using Charles' law, anytime I'm doing gases, I'm always going to make this change. 273, I'm going to have to add that and make that into the Kelvin scale. So 298 Kelvin, and then my temperature 2 is going to be added, again, 273 Kelvin to this. And what that's going to do is make this, what, 523 Kelvin. All right, so what I'm solving for here is my volume 2. So what I'm going to do is I'm going to multiply both sides by temperature 2. So temperature 2 is going to be multiplied on the top. These cancel. My final equation is V2 is equal to my volume 1 times T2 over T1. This is why algebra is a prereq for this course. So if you have trouble with these, manipulations like this, you should maybe see your math teacher or see me and I'll help you kind of figure them out. 10.5 liters. T2 is equal to 523 Kelvin over 298 Kelvin. All right, and I can simplify this and see what the answer is. Well, I've got 18.43. Again, looking at significant figures, I have a 3, I've got 2, and I have 2. So probably should just keep this at 18 Now what would my unit be? Kelvin cancels, so I'm left with 18 liters. So my final volume is 18 liters. All right, so again, what I did was I listed the information, I identified what I was looking for, I used the logic of what we've been studying to try to figure out how to put it together. Now I stop and think about whether that makes sense. Temperature is going from 298 to 523. So my temperature is going up. What did we say should happen to volume if temperature goes up? Your volume should go up. Did my volume go up? Yes, it did. So check that. That would really, it's a good way to make sure you're on the right track. A lot of students just kind of quickly do the problem, and if you didn't do the temperature change, you might not get that correct, ratio. Okay, so that's Charles' law, and we'll look at the rest of the gas laws in class, guys. I'll see you later.